Welcome to another class. We have about 12 questions. Alright, so you could just download the PDF, containing the questions in the description, and then try to solve them before you continue with the video, or just have them and follow along with us as we move along. Okay, so the first question we have is, given that log 2 equals 0.3010 and log 7 equals 0.8451, evaluate log 112. Alright, and this is from JAMB 2010. Okay, so the first thing that should come to your mind here is to figure out how you can split this number into its multiples, okay, that can contain 2 and 7, okay, or how 2 and 7 can combine to give you 112. Okay, so if you can get that, then you can split them into two logs and use these values you have here in your question. So if you look at what we've done, okay, we decided to take 16 and 7, which are multiples of 112. Okay, so we have log 16 plus log 7. Okay, and we know that we can actually raise 2 to a certain power to get 16. And then we have log 2 raised to the power 4 plus log 7, of course. We have our log 2 here, we have log 7 here, but before this, we know that this is the same thing as 4 log 2, alright, plus log 7. So we can now bring in our values, which is 0.3010 for log 2 and 0.8451 for log 7, and then we simplify, multiply 4 by 0.3010, we have 1.204, add it to 0.8451, and we have 2.0451. So the second question is, multiply 2.7 by 10 raised to the power minus 4 by 6.3 times 10 raised to the power 6. And this is a WAEC exam from 2013. Alright, so if we, of course, bring down the question here, alright, we can take like terms. So we would have 2.7 times 6.3 times 10 raised to the power minus 4 times 10 raised to the power 6. Okay, if we do that, of course, we can multiply 2.7 times 6.3 and we'll have 17.01. Okay, while we multiply 10 raised to the power minus 4 times 10 raised to the power 6, which would give us minus 4 plus 6. Okay, and that's 2. Alright, so we have 10 raised to the power 2. That's how we got this answer, and of course it's equal to 1.701 times 10 raised to the power 3. Okay, if we put this in standard form. Alright, okay, so let's move on to number 3. We have, if 9 raised to the power 2 minus x, alright, is equal to 3, find x. Okay, so this is from WAEC 2013, and this is a question on indices. So if we have 9 raised to the power 2 minus x, okay, it's same as 3 raised to the power 2 bracket 2 minus x. Of course, 3 raised to the power 2 is 9, equal to 3 raised to the power 1. Okay, so since we have these two numbers as same, we can ignore them and take their indices, okay, to solve and find x. So we have 2 bracket 2 minus x equal to 1. If we simplify this, we'll have 4 minus 2x equal to 1. So this is same as, of course, 4 minus 1. If we take this to this side and bring this to this side, 4 minus 1 divided by 2x. Alright, so this is going to give us 3 equal to 2x. Okay, making x the subject of formula, we have 3 over 2 as our answer. Okay, number 4. Express 0.21 and 0.34 in standard form. And this is from JAMB 2010. Okay, so to do this, we have 0.21 and 0.34 out here. And so we're going to try to multiply these out. So if we do this, to do this multiplication, we do 4 times 1, that gives us 4. 2 times 4 gives us 8. 4 times 0 gives us 0. 3 times 1 gives us 3. 2 times 3 gives us 6. So we have that here. Then 3 times 0 gives us 3. So we add what we have together. So we have 4 down here. 8 plus 3 gives us 11. We have 1 here. Move 1 to this side. Alright. 1 plus 6 is 7. Then we bring down this 0. So we have 0.714. Okay. But now, where do we place our decimal? So first, know where to place our decimal. We check where the decimal point is for both numbers. So for the number 0.21, we see that we have the decimal 2 places away to the left of the number, while for 0.34 is 2 places to the left too. So it means we're going to move our decimal point 4 places to the left. Okay, so we have 1, 2, 3, 4. So that will give us 0.0714. all right, but another way we can approach this question would be to convert this number to a whole number by multiplying them by 10 raised to power any number that would make it a whole number. Okay, so we have for the first one 0.21 times 100, okay, which is 10 raised to power 2. all right, so if we do this multiplication, we're going to have 21. okay, and then for 0.34, same thing, we're going to have 34 if we multiply by 10 raised to power 2, which is 100. okay, so what we do next is we multiply 21 and 34. We already know we have 10 raised to power 2 for both numbers. okay, so we come here and multiply 21 by 34, and then that will give us, of course, 4 times 1 is 4, 2 times 4 is 8, 3 times 1 is 3, we put 3 down there, and 2 times 3 is 6. So if we sum this up, we're going to get 714. okay, now we have 714. We divide 714 by 100 and divide our answer by another 100. So we have 714 divided by 100, and we divide our answer by another 100. This 100 is the first one here, this one is the second one here. okay, so if we do this, we're going to have 714 divided by 100 times 100. That's the same thing as this. okay, all right, because if this turns to multiplication, we have 1 over 100, okay, which is 100 times 100. So if we simplify that, we have 0.0714, that you can see. okay, so which is 7.14 times 10 raised to power minus 2. Number 5, if log 5.957 is equal to 0.7750, find log root 3 0.0005957. okay, so to do this, we have to put our number in standard form. We take our 0.0005957, put it in standard form. So remember, we're putting it in standard form, so it's going to be easy for us to pick out our characteristic. okay, so if we do that, we have 5.957 times 10 raised to power minus 4. okay, so automatically we know our characteristic is minus 4. all right, and then we have to use this to find our mantissa. So therefore log root 3 0.0005957 is equal to log 5.957 times 10 raised to power minus 4. all right, okay, which is same as raised to power 1 over 3, right? Same as this. okay, so this is also the same thing as 1 over 3 log 5.957 times 10 raised to power minus 4. okay, I'm sure we remember from the laws of logarithm that we can actually move the power or the index of a number, okay, all right, whose log we're looking for. We can move that index to the left hand side of that expression, and then we would not have changed the value of that expression at all. The value of the expression remains the same. all right, so if we get to simplify this, okay, we're going to have that the log of 5.957 times 10 raised to power minus 4 will give us 4.7750. So how did we get this number? We got it by going to the logarithm tables. okay, you go to the first column, the column X. all right, you go to the column, the row 59 on column X. okay, now you check whether row 59 coincides with the column 5. okay, that column 5 reads 7745, exactly where it coincides with column 59. okay, you're going to have 7745. now you go to column 7 under the differences column, like the column of differences. You go to column 7, read where column 7 coincides with row 59. You're going to see that the value there is 5. You add that 5 to the 7745 which you had before, and you're going to have 7750. okay, so that's your mantissa. all right, so we have a mantissa 7750, and we add our characteristic to the mantissa, which is minus 4. But then when you have a negative characteristic, you don't just add it to the whole number like that. You have to represent that negative with a bar. okay, this bar represents that this negative is only for the characteristic, it doesn't affect the mantissa. You have bar 4 plus 0.7750, which gives us bar 4.7750. and then of course we need to simplify this by dividing it by 3. But then you're dividing the characteristic differently, and you're dividing the decimal part differently, because of course this negative sign, okay, on this 4 on your characteristic, is not affecting the full number. It's affecting only your characteristic, not affecting your your decimal part, which is the mantissa. Okay, so you have to divide them separately. So we're going to separate this into bar 4 plus 7750. Okay, so we have 1 over 3, more like we're going to make this more like 1 over 3. All right, brackets 4 bar 4 plus 0.7750. Okay, so this is a bracket. So we're going to have split this into something like this. Okay, 1 over 3 bar 4 plus 0.7750, which is same as this. If you sum them together, you're going to have bar 4.7750. Okay, now to simplify this, okay, we need to divide this characteristic by 3 and divide the decimal part by 3, but 4 into 3 is going to give us issues. Okay, we're going to get issues, so we're going to try to convert this number to a number that can be completely divisible by 3 without any remainder. Okay, so we can have an easy solution to our problem. So one of the things we can do is to add 1 to this side. Okay, if you add 1 to this side, we're going to have minus 3. Okay, which makes it very, very divisible by 3. But if we add 1 to this side, it means we have to subtract 1 from the decimal part. Okay, because of course plus 1 minus 1 is 0, so it will look like we did no change to this, to the value of this number. Okay, we're just trying to modify it but not change the value. Okay, so if we add 4 to this, if you add 1 to this side, we have to subtract 1 from this side, which means we're going to have negative on the decimal part. That's not what we want, so we have to try something else. So if we add if we subtract 2 from this side, we're going to get 6, minus 6. Okay, which also can be completely divisible by 3. And on this side, since we're subtracting 2 from the characteristic, we're going to add 2 to the decimal part, and if we do that, of course we're going to be left with a positive decimal. So it's a good one to try. So we do that here. We subtract 2 from the characteristic and add 2 to the decimal part. So this gives us minus 6 plus 2.7750. So if we divide through this, we have minus 2, okay, plus 0.925. all right. So if we add them together, we have bar 2.9250. So this is the correct answer. Number 6, if log 18 to base 3 plus log 3 to base 3 minus log x to base 3 is equal to 3, find x. Okay, so how do we go about this? So let's simplify this. We know from laws of logarithm that when logarithms sum up themselves like this, we can multiply their values. Okay, as long as their bases are equal, we can multiply their values. Okay, so if they are subtracting themselves, we can divide their values. So we have log 18 times 3 divided by x equal to 3. Okay, so we know from the laws of logarithm that this is the same as this. Okay, this 3 here, this 3 here comes from the base here, and this 3 here that is now a power comes from this. Okay, so we have 18 times 3 divided by x equal to 3 raised to the power 3, and we've lost the log. All right, so by doing this, we've lost the log. Okay, so to simplify this, we have to remember BODMAS. Okay, and from BODMAS, you know, we have division before multiplication. All right, so we're going to divide first. So we have 18 times 3 divided by x equal to 3 raised to the power 3. All right, so if we simplify further, of course, we're going to have 18 times 3 divided by 3 raised to the power 3 here. X goes to this side, this comes down here. So if we do this, we're going to have 18 divided by 3 squared. Of course, this 3 takes care of one of the 3's here. So we have 18 divided by 3 squared, which will give us 2, because 3 squared is 9, and 18 divided by 9 is 2. Number 7. If log x squared to base 3 is equal to minus 8, what is x? All right, so of course, x squared is equal to 3 raised to the power minus 8. We just did something like that now, where this 3 comes from this base, and this minus 8 comes from this one here. Okay, so once we do this, we can lose the log. We lose the log by doing this actually. All right, so s squared becomes equal to 3 raised to the power minus 8. Okay, so we find the square root of both sides to lose this squared here. So we're going to have x is equal to 81 raised to the power minus 1. Of course, we get our 81 from 3 raised to the power 8. Okay, so let's not forget that this is same thing as 1 all over root 3 raised to the power 8, right? And we know that 3 raised to the power 8 is 6561. Okay, so the square root of 6561 is 81. So this is same as equal to 1 all over 81, which is same as 81 raised to power minus 1. Okay, all right, so we have that here to be our x. Okay, so that's how we got our x. So of course 1 over 81 is our answer. It's here. Okay, so for number 8, if log 4 to base 10 is equal to 0.6021, evaluate log 4 raised to power 1 over 3 to base 10. Okay, so what do we do here? We have to take advantage of the fact that we've been given log 4 to base 10. Okay, so log 4 raised to power 1 over 3 to base 10 is same as 1 over 3 log 4 to base 10. Alright, so we already have a value for log 4. All we need to do is to divide it by 3. So we have log 4 to be 0.6021. Alright, if we divide it by 3, we have 0.2007. So number 9, express the product of 0.00043 and 2000 in standard form. Okay, so we can easily solve this problem by making this a whole number. Multiplying it by 10 raised to the power minus 5 would make it a whole number. So okay, so we do 43 times 10 raised to the power minus 5. This is the same thing as what we have here. Alright, so multiply it by 2 times 10 raised to the power 3, 2, which is same as what we have here. So we can collect like terms, and what we're going to have would be 43 times 2 times 10 raised to the power minus 5 times 10 raised to the power 3. Okay, so if we simplify this, of course, we have 86 times 10 raised to the power minus 5 plus 3, which will give us 86 times 10 raised to the power minus 2, and that will give us 8.6 times 10 raised to the power minus 1, which is this. So we have this as our answer. Alright, so number 10, if log 7.5 is equal to 0.8751, evaluate 2 log 75 plus log 750. Okay, so basically we convert this to our standard form. Alright, convert 750, 75 and 7.5 to standard form. So we have 7.5 to be 7.5 times 10 raised to the power 0. We have 75 to be 7.5 times 10 raised to the power 1. We have 750 to be 7.5 times 10 raised to the power 2. So if you look at this carefully, you will see that our characteristic for 7.5 is 0. That's why we have 0 point here. So it means for 75, we're going to have 1.8751. If you're confused about this, please just go back and watch the video of the lesson you did for indices and logarithm. You will understand perfectly. These things are not difficult. Okay, you just know from looking at this that for 75, log is going to be 1.8751. For 750 is going to be 2.8751. So if you have to simplify this, we have 2 log 75 plus log 750 to be 2 times 1.8751. We got 0.8751 here as our mantissa already. Alright, then we add our characteristic to it, which is 1 for 75 and 2 for 750. Alright, so we multiply log 75 by 2, which is what we're doing here, and add it to log 750, and we're going to get our answer 6.6253. So we'll go to number 11. Without using tables or calculators, simplify 0.6 times 32 times 0.04 divided by 1.2 times 0.08 times 0.16. Okay, that's what's expected from 2014 WAEC. Okay, so we have 0.6 times 32 times this over this. If we to make this easy for us, we can split this, so we can put these numbers in their standard form, or we can multiply them by 10 raised to the power any value that will make them a whole number, so we can solve easily for them. So we have 0.6 to be 6 times 10 raised to the power minus 1. 32 is already a whole number, so we'll have a problem. Then 0.004, we change it to 4 times 10 raised to the power minus 3. We have 1.2 here to be 12 times 10 raised to the power minus 1. We have 0.008 to be 8 times 10 raised to the power minus 3. And we have 0.16 to be 16 times 10 raised to the power minus 2. Okay, so if we have to simplify this, let's collect like terms. So we have 6 times 32 times 4 times 10 raised to the power minus 1 times 10 raised to the power minus 3 on one side. Then 12 times 8 times 16 times 10 raised to the power 1 times 10 raised to the power minus 1 times 10 raised to the power minus 3 times 10 raised to the power minus 2. So if we look at this, we would see that here 10 raised to the power minus 3 can cancel this 10 raised to the power minus 3 here. Okay, so we have 10 raised to the power minus 2. 10 raised to the power minus 1 can cancel 10 raised to the power minus 1 here. So we just have 10 raised to the power minus 2 left. Okay, 16 here can go into 32 here 2 times. Okay, alright, we have 4 can do the same with 8 2 times, and 6 can do the same with 12 2 times. Okay, so if we then cancel these 2, alright, we see we are left with 2 and 10 raised to the power minus 2. So our answer is 1 over 2 times 10 raised to the power minus 2. This is the same as 10 squared divided by 2. Of course, we will take this 10 raised to the power minus 2 upwards. Alright, the negative is lost, and we have 10 squared divided by 2, which is 100 divided by 2, which gives us our answer as 50. Okay, so we have our answer as 5 times 10 raised to the power 1. Okay, so number 12, we have express 1 plus 2 log 3 to base 10. Okay, so we have log 10 to base 10 is equal to 1. That's one thing we know. Okay, so we know that log 10 to base 10 is equal to 1. Alright, so which means we can change this one we have here to log 10 to base 10. So if we do that, we have 1 plus 2 log 3 to base 10 to be equal to log 10 to base 10 plus 2 log 3 to base 10. 2 log 3 to base 10 is the same thing as log 3 squared to base 10. Alright, so we have log 10 to base 10 plus log 3 squared to base 10, which is equals, of course we factorize here, we have log 10 in bracket 10 times 3 squared. Okay, 3 squared gives us 9 times 10 is 90, so we have log 10 90, which is already in the form log q to base 10, and we have A to be our answer.